Hi, my name is Patrick Jardins, and today we will create a GraphQL server that will feed itself with the gRPC work that we have been doing in this series on automation of type with TypeScript, gRPC, and now GraphQL. The main benefit is to have this flexible layer that other system or user interface can connect to craft a personal query to get the data they need, while all having the types generated for free. With GraphQL, the consumer of the data does not need to bother about how to stitch all the information together, neither to know which service is needed or where to get the data. The only concern for the consumer is to connect to the GraphQL server. In this video, we will cover the first part of the GraphQL. Stay tuned because I will spread the GraphQL and type generation on about 4 videos. In this episode, I will focus on bootstrapping the GraphQL server, meaning that we will install GraphQL and have it run without having much of the previous work in place. Hence, the coding part will be a little bit thinner than usual. Let's get started with some configuration that needs to be in place, but also some reorganization of our files. In the package.json, we will need to add a couple of packages. There are many ways to create a GraphQL server, and in this episode, we will use the Express server and Apollo. We need to add in the package.json the Apollo server using npm install Apollo server, as well as the Apollo server core and the package about Apollo server express. Then we're going to need to add with npm install the GraphQL library, as well as the merge GraphQL schemas and express. Some types will be required for GraphQL, so we're going to need add types /GraphQL and add types /express. Before creating the server, since we are working in a single repository project, meaning that each of our systems like gRPC, the database, GraphQL, and later the web project is into the single project, we will divide these layers by folder. Let's create one folder for the gRPC server, one folder for the gRPC client, and one for GraphQL. The gRPC client will remain empty for the moment, but we will have a thin wrapper that GraphQL will consume to communicate with the gRPC server. The gRPC client is mostly auto-generated, and in a few episodes, it will be clearer. Let's move to the server file into the gRPC server folder, the server.ts. house.proto, person.proto, and the mapper.ts file can be moved. The folder service as well. The two services reference to the generated types ought to be changed to compile. Similarly, the code inside service.ts and mapper.ts have imports that needs to be adjusted. Then, inside package.json, we need to change all the scripts. Let's change the path, but also the name of the scripts to all have the prefix gRPC and colon with the action. Now let's go in the GraphQL folder and create a couple of folders where we will divide the core principles. Let's create a context folder, a data loaders folder, data source, extension, mappers, resolvers, and schema. As you can see, we will work out quite a couple of pieces of the puzzle to have everything in place, but everything is achievable. Today, we will mostly focus on a new file that we will add at the root of the GraphQL folder, named GraphQL Server.ts. The first step is to add a new app variable that instantiate Express server. Select a port that we want to serve to listen to, and add a testing endpoint, which we will be when nothing is provided, just to ensure that the server is listening. Then we add the listening event on Express. Before going any further, adding GraphQL on top of Express, let's create in the package.json a way to start the GraphQL server. Inside package.json, let's add a script that starts with the prefix GraphQL and colon with start. Then we set tsNodeDev to point to the GraphQL file GraphQL Server.ts. Now let's run the command. No error should be in the console of VS Code. In the browser, running HTTP localhost colon with the port 5600 should display the message that the server is running. Great, let's add GraphQL with Apollo middleware. We need to create a constant server, then instantiate a new Apollo server. The constructor takes the configuration. Let's create a configuration object where we define the important fields. The schema is not yet defined, but we can place the skeleton and fill it up right after this. The schema is where we define all the GraphQL schema, the .GraphQL. And also, we need the resolvers. The resolvers are one or many TypeScript files that returns many functions for each node in the graph. It is the way to determine how to inject the data into the graph. We will create a couple of them in the next episode. We will define the context function because we will use it to specify our data loader. The concept will be presented in about 2 episodes, so stay tuned. While many people use the context for the data source, we define the data source because of the convention. Apollo automatically initializes the data source if you provide an initial function, which can be useful. It also keeps the context clear by limiting the number of different elements. Then we enable the playground, which is a free way to query the schemas. We turn on the introspection, which allows the client, like the playground, to interrogate the server for the schema. And let's turn on the tracing. To be in a position to compile, let's create the context and resolver and an empty data loader. The next episode will provide a concrete examples of why they are needed. At that point, we need to fix the schema with a string for the type def, and let's create an empty resolver. In a new resolver file, this episode has a lot of preparation for the next 3 episodes, but it's a good video if you need to start a GraphQL project and want to get an empty shell. To get the GraphQL started, let's hack a fake schema, which we will change in the next episode. At that point, everything should compile. Let's give it a try. Using the npm run GraphQL start, the server is running, and we can go in a browser and try http localhost with the port 5600/GraphQL, which start the playground since it is a HTTP GET request. Performing a post HTTP with the same address would invoke the service as an API instead of the visual playground. We can see our fake schema on the right side of the playground. In this video, we set in place our files and folders to be more organized. We then created an Express server that is using Apollo server. All the configuration under 50 lines of code. In the following episode, we will implement the schema in resolvers. It will be a stepping stone toward the next video, where we will communicate with the gRPC using the auto-generated client and types, which will save us a lot of time. So if you like the video, please like it, which will give me a sign that it is worth sharing my knowledge. Also, if you have any question or you find a bug, please comment below. See you soon.